Welcome back. I'm sitting down today. Early morning hustle. Not that early, but early enough. And you can do it. So today what we're going to discuss is two independent sample proportions inference. Alright? And so go ahead and read the description. The summary statistics are in the actual paragraph. That's fine. And look at the visualization, look at the analysis, and we'll come back to this point. Okay, so the California Department of Transportation is comparing the effectiveness of two different types of electric vehicle charging stations at highway rest stops. At locations with type A, 182 out of 250 travelers successfully completed their charging session. At locations with type B chargers, 195 out of the 240 travelers completed their charging. The department wants to determine the difference in reliability between the two types. So we're trying to see if there's a difference. So if there is no difference, then the difference between the two will be zero. And so that's important to know. The statistical analysis will provide robust evidence on whether the success rates significantly differ, guiding potential improvements or changes in charging infrastructure. So that's nice for us to know while we're doing what we're doing. So if type A works better, let's do type A. If type B works better, let's do type B. One moment. My apologies. That was a typo. I should have said 250. I'll make sure to change that in your notes as well. So 250. And so here's our visualization. This is what I will call a bar plot still, but it's not it's stacked. My mind went away for a second. Stacked. This is fine. So what we're looking at in terms of the orange, in terms of these bars, we're trying to see if this orange region is statistically the same. Okay, type A versus type B in terms of success. And then in terms of analysis, jumping right into it, I give you the number of successes, I give you the number of trials, I give you the sample proportions, I give you the difference. I give you the standard error for confidence intervals, and if you scroll down, I give you the standard error for hypothesis testing. We'll talk about this, why there's a difference in class. Then I give you the level of confidence, the critical value, lower bound, upper bound, as well as test statistic and the p-value. So in terms of this technique, we're going to do a confidence interval this time. And notice that in terms of the confidence interval, the lower bound and upper bound includes 0. Okay? So including 0, we'll talk about this again in a little bit, but including 0 doesn't mean that there is no difference guaranteed, but based on the data, it's plausible for there to be no difference. So you see how that language is a little bit different. We're not saying that it's a guarantee that it's 0, but it's plausible based on the data that there is no difference, that it can be 0 based again on the data. So with that being said, let's continue. All right. So go ahead and answer questions 1 through 7 and circle back to this part of the video when you're done. So you can imagine working for California and having to deal with this problem in terms of charging stations, and we want to see if A works better than B. And so this is huge in terms of, especially if the infrastructure is already there for some locations that have B versus A. And so we want to see if there's a difference between these two charging stations. Okay? All right. And so then in terms of variables, there should be two variables. One is a location, and then the other is the number of effective charges. Okay? Not the number. Whether a car charges or not. Sorry. Got ahead of myself. So let me say that again. One variable is is the type of charger, A or B, and the other variable is whether a car charges or not. Okay? Okay. So whether it actually succeeds in charging is going to be our response variable, and the type of charger, A or B, is going to be our explanatory. Both variables for two independent sample proportions will be categorical binary. The actual observation Okay, the actual observation is going to be what? A individual charging session. Okay, the actual charging session. Because it depends on we're going to measure the variable, the actual type of charger, whether it's A or B, and whether the actual session leads to a successful charging. All right. So the actual population of interest is going to be all travelers using the EV charging stations at the highway rest stops. Okay, so it's a little long. So it's going to be all the travelers, okay, in terms of using the EV stations at these rest stops. Okay, we're not looking at their homes. We're looking at the rest stops. We're not looking at gas stations with the EV charging stations. You're looking at the travelers. More specifically, the sample is going to be those randomly sampled charging sessions to compare the effectiveness of the two types of charging. This is definitely an observational study because they're not manipulating anyone in any way, shape, or form. Okay, so that's important. And then we're doing a two independent populations proportions test because we want to see if these proportions are the same. All right, so now we can talk about question 8. Okay, again, we want to really emphasize using the confidence interval. So we're going to state the parameter of interest as well as calculate the point estimate. Talk about the assumptions. They're quite long this time, which is fine. Calculate the margin of error, distribution, determine the lower bound, upper bound, and then provide a summary of our decision. All right. So in terms of the parameter of interest, we're dealing with proportions. Okay. So it's going to be the population, the difference in the population proportions, okay? So the difference in population proportion of travelers successfully completing their charging session at type A and type B. In terms of our point estimate, aka our sample statistic, that's going to be the sample proportion, or at least the difference in sample proportions, okay? So that's would be our actual point estimate. And we actually calculate it by looking at the difference between A and B. And again, order doesn't matter here. Okay. Order doesn't matter here. Okay. So, in terms of our decision, in terms of our first assumption, randomness in some way, shape, or form needs to be accounted for. We need to have random samples. Okay. In terms of our sessions, and then in terms of the second assumption is that for normality, we need to make sure that n times p and n times q for both of the groups are greater than or equal to 10. And so this is n times p, this is n times q, greater than or equal to 10, 182, 68, we're good to go there. And then do it for station B, we have 195 and 55, we're good to go there. So the assumption for normality has been met for both groups. Alright, so the margin of error, as we saw in one of the previous videos, is always going to be the critical value times standard error. Okay, so technically I gave you all these values in the analysis up here. So it's going to be the 1.95 times the 0.03845. Okay, I'll give you the standard error. This is the critical value. Okay, we're going to be using a normal distribution because it's a proportion. Okay, and then finally the margin of error to be seen as the product of these two numbers, 0.073. We add and subtract this from our negative 0.052, and we get our lower bound. Oh no. We get our lower bound. We get our lower bound and upper bound, okay, as we found up here, okay. And so then in terms of decisions, it doesn't matter what charging type we have, because based on our data, it's plausible for 0 to be included, which indicates that there's no difference. It could be by chance, but since 0 was included, we can conclude that we don't have evidence to reject that they are the same based on the data. Okay, it could be the true difference between the population proportions could be 0.02, but it's not significant enough for us to reject that claim. Okay, indicating that any observed differences in success rates could be due to chance. Okay, this finding suggests that both types of charger perform similarly in the types of reliability and decisions on infrastructure improvements or changes. Should consider other factors such as cost, user preference, or geographic distribution. So that's that for this video. We did a good job, and thank you for your time, and have a good one. I love my antics.